Greetings, Dr. Mastura and Kuey from 4BMMD1. Today, I'm going to present the explanation that I can explain in the assignment 1. So, the topic that I want to explain today is the different method to fabricate piston. Okay, there are 3 methods to fabricate a piston. They are forge, cast, and hyper-eutectic. The hyper-eutectic piston is actually using the casting method, but it is a bit different with the cast piston. So I will put it in another category. Next, the ground fault is one of the method to differentiate the difference between these 3 pistons. So what a ground fault is? The ground fault is the directional orientation and distribution of metallic grains within a metal part. So to make it short, the ground fault will determine how hard or how reliable the pistons are. Next, this slide shows the 3 different grains in casting, bar stock, and forging. The casting has no ground fault, and sometimes it may contain a porosity due to its manufacturing method. And then the bar stock has ground fault, but it is broken by machine. And then the forging has the 2 ground fault. Okay, a good ground fault is coherent, uniform, and rounded for maximum strength. So this characteristic only the forging had met all of these characteristics. Next, thermal expansion. Okay, the thermal expansion is the expansion of piston inside the engine. Next, okay, this table has shown the different characteristics and different thermal expansion in different fabrication method. Okay, for the forged piston, it has the highest thermal expansion, but it also have the most ductile, so it will suit very well for high performance applications such as the racing car and the drag race car. Okay, but it is also high in price due to the method of fabrication, and then the high thermal expansion have make the highest wall clearance for this piston. Okay, next, the cast piston. The cast piston has medium thermal expansion. Okay, it has 8 to 10% silicon content inside it typically. Okay, it's easy to produce in bulk, so it is cheap and the most cost-effective replacement option. Okay, it is suited for the normal performance application, and then it has the medium wall clearance. Okay, the last one is the hyper-eutectic piston. The hyper-eutectic piston performance is depend on the silicon content. The piston with 12.5 silicon content above is considered as an hyper-eutectic piston. But as you can see, I also put the high silicon content and low silicon content piston inside this category because it is different with the cast piston. Okay, for the high silicon content piston, which have 10 to 11% silicon content, it can improve the wear characteristic, make piston harder, and expand even less under heat. For the low silicon content, which is approximately 2% of silicon content, it is suitable for high performance application. At the same time, it also reduces the heat expansion. And lastly, the hyper-eutectic piston has the lowest wall clearance. Okay, next. Okay, what might happen when the engine is in cold start, which means the engine is put for a long time and it is cold, and then we start it. Okay, when the wall clearance is increased in the piston, it can cause piston slap, and which is the piston is not in the normal direction. It will tilt a bit, and then it will accelerate the wear when the engine is operating in the low temperature. It only will become normal when the engine is operated at the normal temperature, which is high temperature, and then it will expand to fit the size of the cylinder. So talking about wall clearance, what will it affect to the engine? It is the fuel efficient. Okay, so the tighter the piston and the wall of the cylinder, the better the fuel efficient. Okay, next. Okay, this is the graph of how we determine and then the characteristic of different piston. Next, okay, for forge, cast, and hyper-eutectic, which we want to use. Okay, for forge, it is best for the high performance application. For cast, it is the cheapest piston for the normal application. And then the last, for the hyper-eutectic, Okay, it is for the best fuel economy. So after the manufacturing method been introduced, now let's do a simulation about the material that I'm interested with. These two materials are the material they are generally using in the market. They are 4032 T6 aluminum and A390 T6 aluminum. Okay, before we start the simulation, let me introduce what is the meaning of T6. Okay, there are many tempering methods such as F, O, H, W, and T. In this presentation, I will only talking about the T. Okay, so what is T? T is the solution heat treated that alloys whose strength is stable within a few weeks of solution heat treatment, and the T is always followed by 1 or 2 digits. And then T6 aluminum is a solution heat treated and artificially etched. It has no cold work after solution heat treatment, and its mechanical properties or dimensional stability or both have been substantially improved by precipitation heat treatment. So if the product are flattened or strengthened, the effect of cold work imparted by flattening or strengthening are not accounted for in specific property limit. Make it short. So if we using T6 temper method for the aluminum, we better avoid flattening or strengthening so we can fully determine if specific property limit clearly. Okay, now let's start the simulation with 4032 T6 aluminum. Okay, this is the stress simulation. The displacement simulation and the strain simulation. Okay, then let's see how about the simulation of A390 T6 aluminum. Okay, the stress simulation, the displacement simulation, and strain simulation. So after watching the simulation, you may think that I am using two same material, but I'm not. I'm using two different material. It is how the material react with only 100 Newton force that apply on the top of the piston. Okay, so here's the summary of these two material after using 100 Newton as the simulation on the top of the piston. Okay, now let's start to read the table. Okay, one thing to mention is I put the forge 4 at the front of 4032 T6 aluminum is because normally this type of aluminum alloy is used in forging manufacturing method, and then the A39 T6 is usually used in cast. So I put the forge and cast in these two material. Okay, now let's start to read this table with the mass. Okay, the mass of these two aluminum are almost the same, so do their density. And then next, the stress. Okay, from the stress we can see the 4032 T6 aluminum have higher stress resistance than the A390 T6 aluminum. And then the difference of these two materials also can see in the displacement and strain. Okay, the 4032 T6 aluminum has shorter displacement changing and also the lower the strain. Okay, which means under the 100 Newton force, it has changed the less displacement, changing the less displacement, and also the strain mean, which is the force applied on it is lower than the A39 T6 aluminum. Okay, the conclusion is 4032 T6 aluminum is really the hardest material in between these two aluminum. So that's why the 4032 T6 aluminum is is having the price higher than the A390T6 aluminum, choose as the material to manufacturing a racing piston. That's all for my presentation. Thank you.